here we have a problem taken from a well-known textbook called, by authors called Cutnell and Johnson. And it's a problem in vector addition, but instead of adding 2 vectors, we're going to go add 3. And we're going to add the 3 vectors all in one swoop. Okay, so a football player runs the pattern given in a drawing by the 3 displacement vectors A, B, and C. The magnitudes are given. Using the component method, find the magnitude and direction of the resultant vector A plus B plus C. Okay, so we need to know how big, what's the magnitude of this vector, and what's this angle, which is called theta. Now, before we get into solving this problem, I just want to point out something here. So this vector, these vectors, like this one A, it shows A with an arrow on top. Okay, that's a standard vector notation. Okay, but here and here, the vectors are referred to with the boldface notation, and that's pretty standard as well. And these mean the same thing. Okay, whereas this letter A, that's a plain A, indicating that's a scalar. That's the magnitude of the vector A. Okay? And B is the magnitude of vector B, and here's the magnitude for this vector C. Okay, we're going to do the component method, so we're going to say, well, x and y components. So we need to define the x and y axes. So I have taken the liberty of drawing the vectors in a large diagram. Okay. And the thing I haven't done is to indicate what the axes are. So I'm going to, in this case, take a fairly standard x and y. So this is going to be x, that's going to be y. And I'm going to put the origin where the football player started. Right? So this is the x-axis. This is the y-axis. Okay, and now I'm going to start asking the questions. What's the x component of A? What's the x component of B? And what's the x component of C? All right, so what do we have? So for vector A, I'm going to ask what's the x component, and for vector A, what is the y component? Okay. So we get a very lucky break. Right? Vector A goes straight along the y-axis, so the x component is 0. Okay? And the y component is then, what is it? Well, it's the entire vector, which is magnitude of 5 meters, so the x component is 5 meters. Right. Likewise, let's look at B. B is this one that goes along to the side, and you see that one is all x component, and the y component is 0. Okay. And so Bx is the entire length of the vector B, which is 15.0 meters. Don't forget your units. Okay. Then we have C. What's the x component of C? What's the y component of C? Yeah, well, okay, now we have to work for it a little bit. Yeah. So, this vector C is an x component that would look like this, and it's got a y component like this, and that's the right angle. We are given that this angle is 35 degrees, so I'm going to give this a symbol phi, because theta is already taken. They want you to call this theta. So phi is 35.0 degrees. Okay. And the magnitude of C is 18.0 meters. Okay. So that's the hypotenuse here. Okay. So our job is to find what's the x component, Cx, what's the y component, Cy. But that's something we could do because here we have a right angled triangle and the x component is the hypotenuse times that's the adjacent side, right? Cos phi. Okay. And that's 18.0 meters cosine 35.0 degrees, and that works out to 14.7 meters. Okay, and likewise, the y component is magnitude times sine phi, which is 18.0 meters, and sine of 35.0 degrees, and that works out to 10.3 meters. Right. So I'm going to put those in here. X component is 14.7 meters, and the y component is 10.3 meters. Okay, so that is fantastic. Allows us to move to finding what the vector D is, because the x component of D is these three things added together. Right? So AX plus BX plus CX. All right, so that's 0 plus 15.0 meters plus 14.7 meters, so that's 29.7 meters. Okay? That's the x component. And similarly, we're going to do the y component. Okay, AY plus BY plus CY. Oh, I just noticed this should say Y. Right? Okay, so that's 5.00 meters plus 0 plus 10.3 meters. And then that's so 15.3 meters. Now, by now, I hope everybody's figured out that I've made an intentional mistake. So what's that? Well, that's in here, 15 meters. Okay, what we've said is the y component of vector D is 15 meters long, and that's not really realistic, right? If you look at this, the x component of D runs along here, and it's pretty long. Okay, so that's dx, pretty long. This is 15 meters, this is another 14.7. You add those together, you get 29.7 meters. That seems good. But the y component is just over here, okay? And it's much shorter, right? So 15.3 meters on this scale is like this long, and that's too much, okay? Well, what happened? What happened is this, Cy, okay? The y component of C is indeed 10.3 meters, right? But it starts high and goes down in a negative y direction. Okay. So what that means is we should have had a negative sign here all along. Okay. So the y component of C points in a negative y direction, should have a negative value. So there's a negative sign here, there's a negative sign here. That's wrong. And this is going to be negative 5.3 meters. Negative 5.3. That's about the right size on the diagram as well. Okay, so that's just a message to say, don't get caught up in doing the algebra. Right? Once in a while, look at the diagram and make sure things are making sense. And make sure that things that have a negative value, you throw the negative sign on. Okay. Now we got the x component of vector d and the y component of vector d. Right? So we know what the vector is. However, they asked find the magnitude and find the angle theta. So we got to do those things. Okay. The magnitude is easy. It's just Pythagoras, right? So d squared is dx squared plus dy squared. Okay, and so that's right here, 29.7 meters squared, and negative 5.3 meters squared. Of course, when you square it, the negative sign goes away, and this works out to 910.18 meters squared. Taking the square root, you get 30.2 meters. That's the magnitude. Okay. Now we have to find the angle here, and now we know x component, y component, we know the hypotenuse, so we can use sine, cosine, tangent, anything you like. I'm going to use the tangent because it doesn't depend on this number being correct, so just in case I made some blunder. Okay. Because all you have to do is you have to know the opposite and the adjacent sides. Okay. Not only that, I did that wrong. That's y, that's x. Okay. Not only that, we just need to know how long those components are. Right? So we don't need to be bothered by that negative sign. So this is going to be 5.3 meters over 29.7 meters. Meters cancel. And we have a number, it's a pretty small number, 0.178. Okay. And the angle that gives you tangent of 0.178 is 10.1 degrees. Okay. So that's the angle, this angle. And it does look like a pretty sharp, small angle. Okay. And its length is 30.2 meters. Okay, so just to recap, we were able to add three vectors at once by adding the x components together and all the y components together.